How far ahead did you want us to work on this?
Just no, all of number 4. I mean, yeah, the stuff on the left, numbers 1 through 3, I'm not really gonna look at unless we have the time. I really want to focus on the graphic stuff to start.
Okay.
Do you want to focus more on number 4?
Yes, please.
And is this due?
No, there'll be a quiz later. All right, if people feel comfortable annotating, go for it. All right, I got one person jumping in. All right, so let's talk about A. I realize people are still going, but I think we have a pretty close to a consensus on A. So I see most of you drew circles. What's the radius of that circle that you drew?
1.8.
Right, so yeah, this should just be a circle centered at the origin with a radius of just under 2, so yeah, 1.8. Yeah, that should be a circle. And then B, looks like I only have a couple there, but let's talk about B. So we have, we don't even have R involved with this one, we just have theta equals -pi/3. So when you're given the theta value in polar coordinates, essentially, what are you being given?
The angle measure.
That's the angle measurement, right? So, and when we're measuring angles, where is 0? Like, where's my reference that I'm drawing from?
The origin.
Well,
Yeah, as far as angle, it's from the, what would be the x-axis.
Right. So, and that's no different in polar coordinates. So the positive x-axis, you know, straight to the right, that's going to be your 0 or 2 pi, however you want to look at it. So the angle I'm given is negative pi over 3. So I'm not sure who graphed this blue line here, but do we agree with that blue line?
I don't. I don't.
Nope.
I don't know. Honestly, I don't think that would. Yeah, blue line doesn't really make sense, to say the very least.
Let's talk about this. What would be a good equation for this blue line?
Pi over 3.
Yeah, theta equal, I think this is theta equals positive pi over 3. Because really, I mean, if I have a straight line, really, if I have a constant theta value, you all just told me that theta was the angle that I'm interested in. And if my theta is constant, that means I want every point that's on a certain angle from the with respect to this positive x-axis. So yeah, I believe that, you know, this straight line going through the pole at this angle should be positive pi over 3. Having said that, then what should negative pi over 3 look like?
So theta equals negative pi over 3 should essentially look like the opposite line, like the same slope but opposite line.
Yeah, someone can show me.
I'll show you one moment. Something like that.
Yeah, exactly. So yeah, so remember when you have positive angles, you're going to measure counterclockwise. That looks weird. And negative angles, you're going to measure
In
clockwise. So,
self-defense, the stuff is a little bit small on the screen.
oh, I understand. Yeah. I'm not going after anybody. Sorry if I made it seem that way. Yeah, I'll make the next one a little bit bigger. I was having trouble trying to keep all the plots on one screen, but okay. So yeah, this line trending down and to the right should be negative pi over 3. Any questions on that? All right, and then it looks like for C, looks like we have some disagreements. We need to discuss this one. So can someone tell me kind of how they attack this? How did we try to figure out what this graph looked like?
I'll add that I would probably revise my answer to match the couple red ones there.
Why was
Okay. And while I'm looking at the chat to answer Michael, if you're given theta but no r, then every point is at that angle. That's correct, which is why we're looking at a straight line. So Ben, you said you would revise. Why is that?
Remembering the cosine function, thinking back to Mark's lecture yesterday about matching the Cartesian graph to the polar graph of how it cycles through the different values.
Gotcha. So yeah, if you want to, so you could, that's one approach you could take here. You could convert this polar equation into something Cartesian. Let's talk about that briefly. How would we convert this to something in x and y in the Cartesian plane?
Multiply both sides by r.
Okay, so then you'd be r squared equals 2r cosine theta.
And then r squared is x squared plus y squared.
Squared plus y squared.
And r cos theta, my mind just went blank on me. To
Do something, right? So
Yeah.
so, you know, I'm going to clear out everybody's but my own because I need the room. So Over here on A, let me just draw. Let's just draw a point. Just develop the trigonometry real quick one more time. So this point right here is r theta, right? So let's talk about how to put that in terms of x and y. This point is also xy. This length is x. This height is y. And this hypotenuse is r, right? What's an equation that I can use to relate x, y, and r?
Pythagorean.
Yep, that's just an application of Pythagorean theorem. X squared plus y squared equals r squared. And then what does x equal in terms of r and theta?
R cosine theta is
R
x.
cosine theta. Yep. And y is equal to r sine theta. And if you want to build up a little slower to that, you can say that cosine of theta is equal to x over r, and sine theta is equal to y over r. So based on that, I would have r squared equals 2r cosine theta, and x squared plus y squared equals 2x. And yeah, we know that's going to be a circle. We can complete the square on it, and I'll kind of fast forward a little bit just in the interest of time. But if you're not convinced of this, I would definitely review how I know this. But this circle is going to have this equation, x minus 1 squared plus y squared equals 1. So that is one way to figure out where this circle is. So based on this equation, where's the center of this circle going to be?
1, 0.
1/2.
I
It's
heard
a,
1,
it's
0.
a, excuse me, radius 1 shifted to the right by 1 unit.
Right. So here's my center, which means my circle would be something like that. Pretend that's a circle. But yeah, it should be centered on the origin, and it should have a radius, or sorry, centered at the point 1, 0. So it should intersect the origin, look something like that. Did anybody try to handle this circle just by plotting points? Okay, I don't hear that anyone was trying to do that. Any questions on any of these first three here?
I'm sorry, I'm just a little confused. How exactly did you get from r equals 2 cosine theta? What exactly did you do again? I'm sorry. You
Yeah, no
kinda lost me.
So I'll open it up to the room here. So what's this first step? What did I do?
Multiply both sides by r so that you've got r squared on the one side and that you've got r cos theta on the other, because
Right.
we've got those identities with r squared, but not with r. And then we've got the identities with r cos theta, but not just cos
Right.
theta.
Exactly. So yeah, we need another r on both sides to make any use of these. And then from there, it's just this is a matter of conversion. I know that r squared is equal to x squared plus y squared, and I know that r cosine theta is equal to x. You know, is it worthwhile for us to go through this completing the square exercise? How about I have you all walk me through it?
I was going to, rather than that, I was going to ask what kind of intuition you use to plot these, if it's converting
Well,
to Cartesian or what Mark was talking about in class yesterday.
I would probably have done this completing the square thing as well, but I was just wondering what else people know about.
Excuse me, but we got 2 r cosine theta. Why did you not? Oh, never mind. You just added r. You didn't necessarily like square it.
No, we're not. Yeah, not squaring, just multiplying both sides by r.
And I meant more in the sense of how you go about graphing polar equations in the first place. What's your conceptual take on it?
just plotting points. Basically, I choose a bunch of theta values and plot the corresponding, find the corresponding R values and plot them.
I just want to clarify, but why would you want to multiply both sides by R instead of just squaring?
Okay, let's talk about why. So if you square, so really the left-hand side, that would have the same effect, right?
Yeah.
But the right-hand side, that would give us R squared equals 4 cosine squared theta.
Right.
Which is true, but then where do you go from here?
You could just do x squared plus y squared equals 4 cosine squared theta.
Okay. But then what am I going to do to, get rid of this theta?
Divide by 4, I guess.
Okay. So I got 1/4 times x squared plus y squared equals cosine squared theta.
Oh, I see. Because you can't necessarily do like R cosine squared. It just doesn't exist.
Right, exactly. So yeah, the reason you want to multiply by R is to have a means to convert that R cosine theta to x.
Got it.
Good. All right, so I want to go on to this next one because these are going to get trickier. And I'm going to make this a lot bigger. And for right now, I just want to focus on part D. So 3 cosine theta plus 1. And just a bit ago, Ben asked me kind of what Min2 is asking for the completing the square part. Min2, I would like to come back to that if we have time. If I don't have time, I'll write up I'll write something up and send it out later today. But I really want to make sure we talk about this graphing for most of our time here. So R equals 3 cosine theta plus 1, and I think let's go through the first one together. And I think it's a good idea to do a couple things.
So just a quick question, but when you graph it on the polar coordinate plane, do you usually see if it's a circle first or no?
No, I would not. I mean, it's because it's kind of hard to see. In fact, this one here, just looking at it, I'm not sure if I could make this thing. If I could convert it to something rectangular.
Got it.
So we're just gonna stay with polar form here. So something I think is a good thing to do is talk about let's graph this in rectangular coordinates first, just to kind of get a sense of it. And this is something we have a lot of practice at. So we have a cosine function here. What's the period of this cosine function going to be?
2 pi?
2 pi. So yeah, it's just cosine theta. And I'm not quite done grading the written homeworks, but I did about half of them. And this was a thing I saw a lot and just not necessarily looking at what the period is. So that's definitely something we have to keep an eye out for. So another period is going to be 2 pi. So I'm just going to graph one period of this thing. What's the range of this cosine function going to be?
-4 to 4?
I got one vote for -4 to 4.
The range of the y value, I already started plugging in the points, and the range was 4 and -2.
Okay.
Yes.
We got 4 and -2.
I got
So
4 and 1.
Got 4 and 1.
Oh no, 4 and -2. Yeah, no,
Yeah.
I see it.
So basically, this value right here is 1. That's kind of your average value. That's going to be the middle of our graph, the vertical middle. And then this amplitude here tells us we're going to go 3 below that. And we're going to go 3 above. So yeah, I agree with a minimum of -2 and a maximum of 4. And where's this graph going to begin? Where's it going to cross the y-axis?
Start at
It
4, head
crosses the
down.
y-axis at pi over 2 and 3 pi over 2.
No, that's the x-axis.
Oh,
It crosses the y-axis at 4.
yeah.
Actually, since
Yes.
this has a center of 1, finding those x-intercepts is a little more difficult. We actually don't need to worry about that too much. So I know my period is 2 pi, so basically I can just start taking advantage of how I know these functions behave. Aside from the accuracy of it, how do we feel about this graph
Perfect.
here? Perfect enough, right? So this is something we have a lot of practice at, graphing in rectangular coordinates. So I think starting here is a good place to go, because as Ben asked me, what's my intuition? How do I handle these things? I usually just grab a bunch of theta values, just pick a bunch of theta values, find the corresponding R values, and then plot those. But now I have the R values from this graph. I can just kind of, basically, I'm converting this graph to this polar one. So let's look at this first point here. This first point here is going to be 4, 0, right? So if I'm bringing that point to this graph, where would I put that?
Radius 4, so it's on the 4th circle out.
Okay, which way?
Then the angle is 0, so it's going to be on the x-axis.
So yeah, and just like Mark has that cool animation with as theta increases, his axes rotate. But as the exam comes up, you're not going to have dynamic visual aids like that. It's just kind of got to reason through it here. All right, so let's try pi over 2. So this point right here is 1 pi over 2. Go ahead and everyone show me where that's going to be. All right. I agree. Now, I would love to assume that from here to here, I just have like this smooth, something like this. But do I have any way of knowing that, like, can I guarantee that it's not going to do anything funny like climb way out there, things like that? How can I justify that it's just going to be a smooth curve like this?
You move from point to point. Yeah, so
Right, but so I haven't plotted anything between 0 and pi over 2. Like, for example, let's look at this this cosine wave here. If the only points I plot are going to be pi over 2, 3 pi over 2, 5 pi over 2, and so on, then it's going to look like all the radii I pick up are going to be equal to 1, which clearly is not the case. But what I'm claiming to you is this. I am justified in saying that as I go from this point right here, which is, what did I say? 4, 0 to 1 pi over 2. Like, I'm just claiming that the radius is going to decrease from 4 to 1. It's not ever going to be higher than 4. It's not ever going to be lower than 1. And it's never going to be 0. Is it okay for me to say that?
You could say the exact same thing about the Cartesian graph you just
exactly.
drew.
I mean, I'm looking at the Cartesian graph here, and really these are all every point on this graph is an r theta point. And, this graph is here, it should be convincing enough that, I can just go from here to here smoothly like that.
And incidentally, it's a minor little detail, but labeling the Cartesian graph with r and theta really helped square away some stuff in my brain just now.
Good. So now what we have to worry about is, let's start by graphing out this next point. This point right here, what are the coordinates of this point here?
-2 and
Pi
pi.
-2.
Be careful, it's -2 pi, but yeah, we got it. And looks like I already have some, I got a couple of answers. 1, 2 units to the right of the pole, 1, 2 units to the left. Do we like purple or do we like red? Or did I do this red one?
I like purple.
Okay. So pi is going to be the negative x-axis, and we have a negative radius. So yes, I think I want this point here.
Because we're starting off at the left side, because it's starting off with a negative radius, pi is on the opposite side.
Right. Now, the question is, what is going to happen in between those points, in between those angles from pi/2 to pi? So how do we think about that?
Basically, the slope is the rate of change of the slope is fast, and then it progressively gets slower.
Okay. Let me ask you this: when we're graphing this in the polar plane, are we going to intersect the pole?
No.
Okay, I got to vote for no. Anybody else?
If we were going to, we would have to cross the theta axis in the rectangular graph at, I'm trying to think through how that would look. Definitely at the origin, it would be crossing the pole, but it would have to also be at the period.
Well, okay, so let me just respond to that with a basic question. Does our rectangular graph cross the theta axis?
Yes, twice.
Yes, it does. So that tells me I have points that look like this. R theta equals 0, and I'll just leave it as theta because I do have crossings. I have x-intercepts, or I guess I should call them theta intercepts, which means I do have points where I'm going to cross the pole. So now let's talk about where those might be. We're not going to find them exactly because we're just sketching here. But about what angle am I going to have that zero crossing?
Smidge past pi/2.
Right. According to my graph here,
than...
I know that as I go from theta equals 0 to theta equals pi/2, I went from 4 to 1. And if I let theta increase just a bit more, I am going to get to 0. So basically, as my angle rotates from here, a little bit, I'm going to get back to 0. So basically what this graph is going to look like from there to there is going to be, it's still going to be positive, and then it's going to finally decay to 0. Are we okay with that?
But what about -2 pi? We haven't connected that dot yet.
-2 pi? Oh, right. So I got you. -2 pi. So that's another good question. And yeah, that's where we need to talk about next.
Because we haven't connected the dot yet from 4, 0 to -2 pi.
All right. So I'm going to give that back to you guys. So think about, pay attention to the rectangular graph here. And what I want you to do is this. What's this graph going to look like as I get from this point here, which is r equals 0, to this point here, which is -2 pi? What is the graph going to look like between those 2 points? So go ahead and annotate when you have some sort of idea. All right, I'm seeing a lot of good things. So, and the thing I was worried about was, I think obviously I haven't seen anyone draw it, but I think the temptations there is like, all right, I got 2 points on the x-axis. The simplest thing to do is connect it with a straight line. But hopefully that Cartesian graph, it looks like the Cartesian graph talked you out of that. So now here's the good news. We have graphed exactly half of this graph. We've sketched exactly half of it. So the beautiful thing about cosine and cosine waves is they're completely symmetrical. So the behavior from 0 to pi, is very closely related to the behavior from pi to 2 pi. So based on that, could I ask you to draw the remainder of this graph? Give that a shot. Oh, Ben's already on. Okay, I'm seeing a lot of good things. And let me ask you a true or false question here. True or false, this graph in the polar plane is symmetric.
False.
What
It's
type of
false.
symmetry?
Oh, Mark said
It,
false.
it's a mirror across the x-axis.
Okay, and then Ben's is symmetric across the x-axis.
Oh, that's true. Never mind.
It is true. So that's what I want to make sure, because I see a lot of the things you drew were, had more quote unquote mass below the x-axis. And I didn't know if that was intentional or if that was just a product of this being hard to draw on.
Drawing with a mouse on
Yeah.
Zoom.
Okay, that's what I figured. But yeah, and in fact, just for, I'm going to be arrogant again and clear everyone's drawings out, but really we should have something that looks something like this. So I better make it symmetric now that oh, that's pretty good. But yeah, the graph should look symmetrical about the x-axis, something like that, with that loop in it.
The far right end would be smooth instead of pointy.
It would be, yeah. Yeah, I mean, if you, again, relating to this, this graph right here, they look nothing alike, but this graph right here is just a representation of this one. So it wouldn't make sense for either one of them to have, hard corners on it, basically. Should be smooth everywhere. Any questions on this first one? Okay, I am going to clear everything out. We're going to go to E now. And I'm going to back off a little bit, but what I think you should do is this. I think you should, I think a good first move is to graph this in rectangular form. So I'll give you a couple minutes to handle that rectangular graph, and then I'll ask for some annotations here. I'm purposely leaving off the labels on the axes because that's an important part to pick out here. So a couple minutes, I'll ask for annotations in just a bit. All right, go ahead and annotate if you got something. All right, so I'm seeing a lot of good things. Yes, the amplitude is 5, so we should, and there's no, the average value of this guy's going to be 0. So we have a range of -5 to 5. Period is half of what it was for the last one. So we're going, basically, if we go from theta from 0 to pi, we should get the entire behavior of this graph. So now I think we're good to go. What do you think? Can we just start going to the graph, or do you want me to lead you a little bit?
I'm ready.
Okay, I got 1 vote for ready. Let's go after it. Let's just if you want to just start by plotting a few points, or if you think you can go for a large portion of the graph, go for it. And I'll check in with you just a bit. So it looks like somebody has plotted points in the 3rd and 4th quadrants. How did we get those?
I think they're plotting the points straight from the graph, but I don't know if
So
that's right.
keep in mind that actually, can you get those? Pi over 4. Oh, that could be the case. Okay. One thing the point that I wanted to make, and I didn't quite do it, was so we graphed a single period of this, which is fine. Goes from 0 to pi. But remember, a polar graph goes from all the way up to 2 pi. So you're going to have to do the same here. So think about what this graph would look like if we carried it from pi to 2 pi as well. So I see one curve we've drawn, but it's not capturing all the points that are there. Now it does. Are we okay with this graph here? Or does somebody else want to jump in?
And that was a big conceptual thing too, that the polar graph is from 0 to 2 pi, which suggests that you could draw other kinds of polar graphs with not necessarily from 0 to 2 pi, but 0 to pi or 0 to 20 pi or anything like that, just by changing the radians per angle.
Yeah. And it all depends on what the argument is of the curve you're trying to make, because I believe, and maybe you all have convinced yourselves of this, or maybe I'm wrong, but if you were to just graph this portion of the curve, I really think you're only gonna get 2 of these petals.
Yeah.
Okay. So because of that, and really that's because as you graph the thing we graph, you're just going from, you know, theta is in this interval of 0 to pi. But really that doesn't graph the full behavior. So, and I think, actually, I'm very confident that you know that you could easily graph this from pi to 2 pi, you know how it behaves. So in knowing that, you could just continue the behavior of this graph and get all 4 of those petals. Which it looks like at least a handful of you have done. Any questions about how this one got generated? So just to kind of I'm sorry, go ahead, Ben.
I was going to say part of the moral of that is to make sure that you always go at least to 2 pi, if not more.
If not further, right. So one of the things on the written homework that I've seen a lot of people do is, I think it was the very last, whatever the last one that you actually had to do was, I think it was number 7. But a lot of people's graphs were incomplete because they went from 0 to 2 pi. And the function looks something like this, where the argument was pi over 2 or theta over 2. So what's the period of a function that looks like this?
4 pi.
4 pi. And I can tell from your graphs, a few of you, that you only let theta vary between 0 and 2 pi, because there was a large swath of that graph that was missing. So basically the moral of the story is this: you need to let theta needs to go at least to 2 pi because of the polar plane represents angles between 0 and 2 pi, but you also need to let this argument here vary from 0 to 2 pi. And since I'm cutting all those angles in half, I need to double. I need to extend that from 2 pi to 4 pi. Does that make sense? Anybody else have any questions before I?
Sorry, it might be a dumb.
No, it's not. Go ahead.
How did you get 4 pi?
I'll let somebody in the room answer that if they can. How do we get the period of 4 pi from this thing?
Just plain cosine has a period of 2 pi. This is half of that, so so you've got to double it.
Right, and
That was
by a
poorly
similar
worded.
logic, what's the period here?
Pi.
Just pi.
Pi. But yeah, sine and cosine. Yeah, if it's just basically the moral, the bottom line is this: I need this argument. So whatever is in the parentheses, whatever you're taking the sign of, the full period comes from that argument going, or like having a full 0 to 2 pi change. So if I double all the changes inside this argument, then that means theta only has to vary by half as much. On the other hand, if I'm cutting in half, all those variations, then I need to do twice as many of them.
Okay.
Does that make sense, Kevin?
Yeah.
Okay.
It's like backwards from what I thought.
Yeah, so what probably is a little more intuitive is, and this will make more sense for people who have a little bit of a physics background. You know, this 2 here, really, I am doubling the frequency. By changing this from, theta to 2 theta, I am doubling the rate at which these angles take place. Or in this case, I am cutting in half the rate at which these angles appear. At which
Okay.
the rate at which the angles changes, the angle changes.
So you'd need a longer, in that case, you would need more.
Yeah, you need
All
a
right,
longer.
just
You
see
get
how it
twice
behaves.
as many waves in the same amount of space.
Okay.
Yep.
That makes sense.
All right. I have 1 minute left. So what I'm going to do is this. I'm going to go ahead and stop sharing for now. I'm going to go publish the quiz because it has not been as of yet. But I will stay in the room if anybody has any questions they like to stick around for. Otherwise, by the end of the day, I owe you all a couple of YouTube videos and a little bit of a tutorial or a refresh on how to do completing the square. Edward's asking if the quiz is due midnight. That is correct. All right, thank you all. See you in class tomorrow morning.
Thank you, Steve.
Thank you, Steve. Have a good day.
Of course, you too.
Hey, Steven,
Yeah, Kevin.
would you mind pulling up one of the previous examples and just walking it through with me?
Yeah, absolutely.
I'm just a little confused. I'm like, it's probably just because I haven't looked at functions like this for a little while. So I'm
Yep.
a little stuck on how to get started.
All right, take your pick. Which one do you want to look at?
D.
D, you said?
Yeah.
So, and I'll let you drive. Like, how do you want to start?
Well, doesn't 3 tell you the amplitude?
Yeah, absolutely. So I know the amplitude is 3. What else do I know?
And then this argument has something to do with the period, right?
Yeah. So yeah, let's talk about the period as well. Which is how much? What's the period going to be for D?
Is it 2 pi?
2 pi.
And then does the +1 mean that the whole thing shifted over?
Yep. So basically, I call that the average value. Other people call it like the center line or the middle or something like that. But basically, the average value is 1. So from that, so basically from the amplitude and the average value, I can figure out the range. So what's the range of this function?
Is the radius 3?
Well, the amplitude's 3 because remember I think a good first thing to do is just graph this in rectangular
Right.
coordinates. So basically, yeah, the amplitude, or I'll ask you, what does the amplitude of a function mean? The amplitude of a trig function.
Doesn't it have something to do with its max and minimum value?
It has something to do with it, but yeah, it's not quite equal to that.
Okay. Like it's
Basically,
the distance. Oh, sorry.
Oh, you go ahead. I think you're about to say it.
I was gonna say, is it the distance from the x-axis that like the curve takes?
Not specific with the x-axis. It's from whatever this average value is.
Okay.
So I know, basically, vertically speaking, the middle of this cosine wave is going to be y equals 1.
Right.
And then amplitude tells me I'm going to vary my amplitude above that, so 1 plus 3. And I'm going to vary my amplitude below that, so 1 minus 3.
Okay.
And then I know that my period is 2 pi, so I'll chop that up into 4 pieces. Because cosine and sine both behave predictably.
Hmm.
So this is a cosine wave, so where's it going to start? On the y-axis.
Through 1?
Cosine
Or is it
actually
going to start? Oh,
it's going to
sorry.
start.
Sorry.
It's going to start at 4 because yeah, cosine of 0 is going to be 1. So
Okay.
3 plus 1. Period's
The
2 pi,
sine,
so I know it's going to have to come back there.
the sine start through the origin?
Correct. Yeah. Or it starts at whatever the average value is.
Okay. 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 Makes sense.
Um, and then the way I usually handle cosine waves is, so I know the period, so I know wherever it starts, it has to be at the same place 2 pi later, or whatever the period is after one period. I know right in between those points, it has to be in its minimum. And I know in between a maximum and a minimum, I have to be in the middle of those two.
Okay.
So yeah, but from those 5 points, I get this familiar shape.
I see. How is the range different from the period?
The period, though those two things aren't actually the same thing. So let me write down the range. I said -2 to 4. So what does the period mean?
I assume the length of the x interval that you're looking at.
Well, that's just because yeah, but why did I draw this x interval that way? Like, why didn't I go out to 4 pi or just stop it after a single pi?
Oh, I don't know exactly. Maybe because that's all there is to see between 0 and
Well, I
2
mean,
pi.
that is one complete period. So that's one complete cycle of this wave. But really, I could have drawn this out to like 10 pi and just drawn 5 of this exact shape.
Hmm.
But the period is just because the period is basically whatever the period is, the change in theta that has to occur to get one full cycle of this cosine wave.
Oh, okay. Okay.
Which is why I stopped my x-axis at that number, because after 2 pi is just going to repeat indefinitely.
Right.
But the range, so really the period is a horizontal measurement of some kind. It's a measurement of theta.
Right.
But the range is a vertical measurement. It's a measurement of r.
Okay.
So they're not really related. Yeah, I could change this period to whatever I want and still have this range, and vice versa.
Okay.
Because I'll give you an example. If I had r equals 3 cosine 6x plus 1, or 6 theta plus 1, that would have the same range. It would just have a much different period.
Would it would you divide pi by 6?
Divide 2 pi by 6. Yeah.
Okay.
So the period
Oh,
would
because
be
it's cosine.
well, same with sine. Cosine and sine. So cosine and sine have a fundamental period of 2 pi.
Okay.
And you can always create the same graph from either sine or cosine by shifting the period.
Not shifting the period, but like shifting.
That shifting the whole thing to the left or the right.
Yep. Which you do by adding or subtracting from theta.
Inside the argument?
Inside the argument, yep.
Okay. Wow. Sorry, man. Sorry, I'm taking up all your time.
No, you're good. You're good.
How would you? And then I'm also stuck with like actually plotting it on the polar coordinates graph because
Yeah. So I mean,
did you say earlier? Did you say earlier that you can't take like direct points?
no, you absolutely can, and that's more or less what we did. So just to
Okay.
kind of recap the way we did it, I know this first point here is 4, 0.
Right.
So if I take that to my graph, I know theta equals 0 is just the right.
The x-axis.
So I can just plot my point 1, 2, 3, 4 units away.
Okay.
And then the same thing for pi over 2, 1. Pi over 2 is the positive vertical axis. And then that point is 1 unit away from the pole.
Right.
And because I know this function is just strictly decreasing from 4 to 1, like it's totally continuous, it's never negative, it's never above 4, I know I can just decrease, more or less uniformly to 1.
Right. Okay. For E and F, would the average values be 0? Well, not for F, but for like E, would it be 0?
Yeah, and what would it be for F?
-1.
There you go. Yep.
Okay.
Yep.
Makes sense. Thank you so much, Stephen.
Yeah, no problem, Kevin.
Have a good one.
You too.
Thanks again. I like your ways of building intuition about these kinds of things.
Yeah, of course.
It really
Not a
helps.
problem.